So yeah, we can start with the introduction of the panelists. I think we'll go in alphabetical order. So Andrea, why don't you get us started?
Yeah, sounds good. Can everybody hear me okay? Hopefully, sometimes I have weird audio problems, so I just want to make sure that that's all set. Hi, everyone. I'm Andrea. I just finished my second year of mechatronics engineering at Waterloo, and I'm currently working as a data engineer at RBC, working under the cloud security team. So it's a fairly new place where they're bringing in data engineering, machine learning into this realm. Essentially, my job has been to kind of work on a POC this term, essentially trying to figure out where we can use machine learning and data science to help increase our security posture or help sort of secure the posture that we have in cloud at RBC. So this is my first co-op term working in a data engineering type of role, and it's been very interesting, learned a lot of stuff. So for maybe those of you who are trying to get into data engineering and stuff, I could possibly be of help in that aspect. So yeah, that's a little bit about me.
All right. First of all, the thing that Andrea did, where she asked if you guys can hear or not, is like a really good thing. Apparently, I read like a LinkedIn tip where you're supposed to do that like before an interview. But anyway, my name is Jay. I'm a third year physics undergrad here at Waterloo, and I've previously worked in data science at Scotiabank, developing recommendation engines, and TD developing a bunch of machine learning models, and recently I worked at Intact, developing a bunch of loss cost models. And next term, I'm going to be working as a data engineer at a startup called Snap Travel. Yeah, that's just like the bunch of stuff that I've done. Interested in things around NLP and data engineering recently. And I also run the podcast for the UW Data Science Club. So if you guys are interested in learning more about data engineering, data science, etc., that's like a place where maybe you can learn more about it. So yeah.
I'm not sure who's next, so maybe I'll just go.
Hey. It is you.
It's you.
Cool.
It's you.
Hey everyone, my name is Nick. I'm a 4A computer science and statistics student here at the University of Waterloo. In terms of my past experience, I've kind of done data science for fraud detection at Manulife. I've worked on kind of open source machine learning libraries while I was at Google. I've worked on kind of machine learning research for self-driving during my time at Uber ATG. I've done kind of some performance optimization and machine learning engineering while I was at NVIDIA. And I've also kind of done, in addition to the research I was doing at Uber, I did like a bunch of undergraduate research assistant terms at the University of Waterloo. So I hope I can provide some insight on some of those areas. In terms of the areas I'm most interested in, I guess my interests are pretty broad, but I've been mostly in deep learning as of late.
Yeah, and our last panelist.
Thank you. Hey guys, my name is Yatin. I'm a fifth year double degree student doing CS and BBA at Waterloo and Laurier, and I'm majoring in data science at Waterloo, finance at BBA. And my experience is a little bit unconventional, I would say. Didn't really get into data science as a data science person, so to speak. My first introduction was at Toronto FC, where I built some geometric models for player detection and pattern detection on the field of play. Since then, I did some ad hoc data analysis and dashboarding at the Globe and Mail, the newspaper, and for the digital team over there. And my previous two terms, including the one I'm currently at, I worked as a data analyst for Wish. My previous term, I did mostly data engineering, building internal tools for data visualizations and analysis for business stakeholders. This term, I've been put in a mix of data engineering and data science. So on the data science side, I've been tackling a lot of business problems, kind of building experiments. And on the data engineering side, more of the same, really, just developing internal tools using Spark and Python and Go. Yeah, so my fields of interest or my topics of interest are also a little bit in line with those. A lot of it is sports analytics, really interested into that. And data engineering, ETL, and just kind of solving business problems using data. That's kind of what I'm fond of.
Wow. Thanks a lot, everyone. That was amazing to hear. We have a diverse set of people from different fields in data science with us today. So what we have done is we've actually prepared a bunch of questions. which we are going to ask, so that we can try and answer most of the questions that students generally have. And what we also have is another 10-15 minutes extra. If we have more time left, we can get to the questions that are asked by the people in the chat itself. And while a speaker, if they're speaking, you can ask them questions in the chat at the same time, so that we can ask those questions to them and make sure all the questions are answered. So I think we can get started with the questions now.
Yeah, so once again, thank you everyone for giving your great introduction. I'm sure our guests are very excited to hear you and your opinions on various questions. So I guess we can start with our first question that has already been sent to you. The first question is, how did you get involved in the data science industry per se? Or maybe, I guess a better way to ask is, how did you find yourself getting connected and sort of involved with a career or discipline related to the data science industry? I don't know, do we want to go alphabetically again, or do we want to, yeah.
I would say we do alphabetical again. It's probably easiest.
Okay, sure. Andrea.
Yeah, so I kind of got into data science just because I was interested in it. So I've done a couple of terms at RBC, and I've done everything from like developer to technical systems analyst. So I've kind of done like a whole variety of things that I think more related to mechatronics specifically, and more like on the engineering side of things. Data science kind of was a realm that I was curious about, and that there's like a lot of potential for. And I think very early on, when I was like sort of looking at potential job roles in the future of where like technology is going to be taking us, data science plays such a huge role in it. So then when I was offered this position of this kind of new territory of using data science in a cloud environment specifically, I kind of jumped on board. So it's kind of like a fluke that I got into data science. It was more so trying to like see what the possibilities are out there, and kind of test the waters and see like what is out there and like how I could use it to sort of gain or grow as an engineer. So yeah, not a very interesting story, but it's how I got in here for sure.
That definitely is very interesting. Also, if you guys do have any questions, just feel free to either privately send it to Vedant or myself, or just send it to everyone in the chat. That'd be great. Okay, we can go ahead with Jay.
Yeah, so for me, it was, to be completely honest, kind of random as well. I transferred from computer engineering to physics, and I wasn't really sure what I wanted to do. I knew that I didn't want to do research. I joined physics to actually do research. I wanted to do quantum computing and stuff, but I realized that that's like really not for me. So I Googled, okay, what can I do which is kind of lucrative, but still like, I can do as a physicist. And I remember seeing like data science, an article about like how this person went from physics to data science. And that kind of like piqued my interest. And I thought, okay, maybe I can become a data analyst. But I did not get a data analyst job. So I actually ended up working in research for that first internship after joining physics. And it was trying to forecast some, price of some fresh produce. And, I was using a bunch of models, doing some data engineering, etc. And I happened to kind of build like a web app for them, on the side, which was like their Dropbox of sorts, because we were poor. So basically I did that, and I was able to like kind of leverage that, use that to get a data science position where this like Scotiabank, this specific lab was building a web app, which is a recommendation engine, and they were building in the same framework that I built my web app in. So that's kind of how I like pivoted to data science. And ever since then, it's just kind of been like very easy. So I worked in data science and did a bunch of machine learning, and then I used that to do some other machine learning stuff. And then I used that to do like, it's just kind of, ever since then, it's just kind of been simple. But yeah, that was how I entered data science.
That's really cool. So we have a mechatronics engineer and we have a physicist as well. So data science is quite a diverse field. I think it's Nicholas next.
Yeah. So I guess before I did data science, I kind of tried different kinds of, I was like always interested in tech, and I tried different roles in tech, in particular, like kind of engineering roles or development kind of roles. And I didn't find them as interesting as maybe I wanted to. And then I kind of encountered this idea of machine learning, and I took like the classic 2012 Stanford Andrew Ng machine learning course. And then I thought, okay, this is cool because I like math, I like tech. It's like a good combination of the two. And from there, I started, getting into Kaggle a little bit and doing some data visualization and analysis. And then like that kind of snowballed into kind of the co-ops that I did. In terms of like ending up in research, I don't think I've like settled on what area of data science I want to be in the end, but it's kind of been my goal to try as many as I can, as you kind of heard from my experiences. And so, yeah, I'm still kind of looking for where exactly I want to end up.
Yeah, that's very good. I like how it's very spontaneous, and then I don't know. I feel like you just get into things that you really like. That's very good. And our last panelist, last but not the least.
Yeah, so for me, I kind of alluded to this in my introduction. A lot of my motivation to work with data and tech came from sports. So I kind of ended up in this community of Twitter data analysts for soccer, very long time ago, like 5-6 years ago. And then I think in the summer of 2017, I saw a posting that Toronto FC is looking for an analyst within the community. And so I kind of shot my shot. That was the only job I ended up getting that term for co-op. And so I found myself working with big data for a field that I was passionate about, which was soccer at the time, and actually making an impact using all the things that I learned in school. And since then, at the time, I was only in computer science, but actually interacting with big data and building some libraries for tracking stuff and again, like geometric models, that really inspired me to actually fully put myself into data science. So from there on, I exclusively pursued only data positions, so data analyst, data engineering, data science. And yeah, that's how I kind of ended up in this, fully committed now. No kind of point in going back to software engineering, even though it's all the same.
That's really cool. Even I'm a big fan of soccer, and I really want to like explore, like personally, if I want to explore the data science industry, I really want to explore how it is used in sports. So that's a really good perspective.
I would definitely say that currently is right now is the best time to get in, because I think the software analytics industry is in a hiring boom of software engineers and people who are capable of working with data. So if you're interested in soccer and you know your way around the advanced metrics that are used in the game, right now is the best time to apply to some of the clubs in the MLS and even in the Premier League.
That's solid. So like we'll move on to the next question. So this question is like, what do you think from your perspective is like the biggest challenge the data science industry is facing right now? Or you could speak about more specifically your field. For example, Andrea can speak about what is the biggest challenge data engineering is facing right now and so on. So yeah.
Are we still doing alphabetical?
Yep.
Okay, cool. I think personally, just because of the fact that I have been working on a project where data science really hasn't been very involved within the field, I think the biggest problem that we see from my end is trying to give it like value and trying to put it into production. Like so far, we've been working on different test cases on different applications that we have in the cloud right now. And all of it is great. The models are fantastic. Life is great, but attempting to speak to the upper management about it and saying, okay, like, why do we need to productionalize this? Why will this be of benefit? I think for me, like, I think that has been the biggest struggle is like, you have all these models, but putting it to production and kind of doing the maintenance of it, there's not a lot of people who can do that. Personally, on my team, there is only, I think, one other person who I would say would be qualified to even kind of sort of support that. And I think finding the proper support to work on these models and have that ability is one. And then also trying to find the rationalizing it to the upper management saying this is something that we need. Yes, the upper management will say like, yes, this is like definitely data analytics is the future. This is where we want to go. But in terms of getting the support behind it and trying to figure out, okay, how is this going to work in the case of like this like corporate system that isn't really that agile? How do we get that running? So those are just, I think, some of the smaller things that I've seen as I've been working specifically on my project.
That's interesting. So you think it's harder for data science right now to replace the state of the art techniques, right?
Yeah. So I think right now, I think at RBC, we do have like a huge data analytics team called our Joint Security Operations Committee, and they do a lot of kind of sort of not high level, I would say, but they are like very kind of specific, driven, like they're very like professional people. But for some of like the day-to-day cases, for outlier detection, some of the regressions that we have to do, there's not really there's not really like a set team to help out with that and support that. So I think trying to figure out how we can bring data science, not just in this like specialized field, but kind of spread it out throughout the company. Yeah, hopefully that kind of made sense.
No, for sure that did. And next we have Jay.
Yeah, so to be honest, I agree with like Andrea, because I think that data science is not a field that is done on its own. You need a lot of supporting pieces around it. And I think, as you can see just from the panel alone, it shows you the different areas of data science, right? Data science alone cannot support all the functions you need. You need a lot of things which support it. So you need data engineers, which are building the pipelines. You need people who are sourcing the data and putting the data together. You need software engineers to be able to productionalize and maintain the models. There's a lot of infrastructure which needs to be built before you can even do data science. And I think that it is not an easy win, for companies. It's a long-term kind of goal. And a lot of the companies, because of the hype around it, right? What hype creates is these like set of emotions. You think that, oh, if I get into AI, if I start using some AI models, I'll gain quick wins. But it's really not that. It's really a long-term play. And the companies which really succeed in that they play a slow game where they build one by one each structure and then are able to do effective data science. I think something that a lot of people will notice when they go to a lot of companies is that they lack the infrastructure which is required to do to do good data science. And you'll see a lot of like Jupyter notebooks just like being hanging around with like random names somewhere, and you have no idea how do you productionalize that. The databases don't make any sense, right? Like a lot of things don't make much sense, and that is where I think that actually provides opportunity, right? That's the biggest difficulty, but that also provides opportunity for a co-op to go in and to be able to make a big change, because it is a field where a lot of companies are not very mature in it, right? So let's say if you learn a little bit of data engineering, right? Andrea learns a little bit of data engineering. She goes to her next job and she learns that department is not doing data engineering well. Now she can implement things that she's already learned and make that better. So that's an opportunity as well as like a difficulty in the field.
That's really cool. So basically, whatever the difficulty is basically an opportunity for any co-op student to go there and try and use their knowledge to actually improve it. So that's good to hear. Nicholas?
Yep. Yeah. So I guess in my opinion is kind of I agree with the previous two speakers have said. Maybe I want to offer slightly different challenges, more on the side of like bias and ethics. I think this is like a really huge issue, especially as more and more tasks are being automated by data science techniques and tools and models. Like these problems become more and more prominent. Like I'm sure many of you have heard kind of the classic example, well, not a classic example, but like a recent example where in the US, they use like models to identify whether a perpetrator was like guilty or innocent. But the problem is the data that they trained this model on was extremely imbalanced. And so it ended up like disproportionately judging African-Americans as guilty as opposed to like non-African-Americans. But the sole reason for that was because the data they were training on was unbalanced. And furthermore, if they implemented this model and continue to use this model and continue to disproportionately find like African-Americans guilty, then there's like a feedback loop where the data you train on is poisoned by the model that is doing inference, right? So you have this feedback cycle. Another recent example is there was a generative model, which is, it's not super resolution, it's like a newer version of super resolution, but essentially the idea is you can take like a low resolution image and you can kind of infer the missing pixels in some sense. And so you can kind of get a higher resolution image. And it showed that like this data set was very like, I mean, the data set it was trained on had some bias as well, where, for example, given like a really low resolution image of Barack Obama, when they upscaled it, they like changed the image to like a person, someone of like Caucasian descent, which is like, incorrect. And it's like, you can't even say that Barack Obama has a like an unpopular face because he's like been the face of the US for 8 years, right? And so I think it's very important for, and so like, when there's things on one final example is like Google Translate, when you have languages which have like male and female nouns, I think, versus some languages that don't, when you translate between the two, there's like, it'll inject some biases, like for example, saying things like he is an engineer or she is a nurse, whereas the original language had no like pronouns or gender inflections. And so like, when you are just interacting directly with a model and there's a human in the loop, you can kind of identify these things. But as these models are kind of put into automated decision-making processes, it can be hard to detect. So like we need to like make an effort to, first of all, detect and monitor these models. We need to have like a theoretical understanding of how these models are susceptible to biases in our data. And we also need to understand our data very well so we can like, correct these biases and, produce models that are fair and ethical.
Yeah, that was very insightful, but like that was something that I didn't know. And I think the whole issue with ethics and biases and everything, that's in different fields, I guess. But I guess like how you mentioned about the whole pronoun stuff and how Google Translate doesn't really recognize, that was something that I hadn't really thought of that, but that was very interesting. Yeah.
Yeah, and just to add on, like for me also, like personally, whenever I type on Word and when I type my name, it shows as the name is spelled incorrectly, but it's my name, and I know the spelling of my name. So why should there be a red underline under my name? So yeah, that's really good point.
Yeah.
All right, so for me, I would say kind of echoing Andrea's and Jay's thoughts. Also, there's a lot of ambiguity, I would say, in the field itself. Like, I think what people get obsessed with is you have a very sanitized data set and you use it in a fourth year course, in a machine learning course, and you're like, this is data science, right? But I think that it doesn't expose you to entirely all the questions that you need to be asking. You're not going to always have a sanitized data set. And I think what we're doing is a lot of it online, these boot camps, or maybe even going on Kaggle to an extent. You're learning from data that is already clean. So you're not actually practicing data science. Because in my opinion, I think data science comes down to 3 steps majorly. You have, what is the problem I'm trying to answer? What is my data that I can use with it? And what is the correct approach to solve this? And in a lot of places online, when you're learning, you're only learning the last step. You're only learning what model can I use to solve a problem that is already given to me. The more important things, in my opinion, are learning how to formulate problems and learning how to sanitize data or collecting that sanitized data. Because at the end of the day, data science is really just garbage in, garbage out, right? So whatever you put in is what you're going to get. You're not going to put in dirty data and get out good results. So I think that's one thing. And I think this ties into the fact that there's a lot of ambiguity where you can say in 3 or 4, you can handpick a set of companies and you can choose their data scientists, and they'll be doing completely different things. Some data scientists will be doing mostly software engineering or data engineering. Some of them will be actually just be interfaces for business stakeholders so they can communicate technical things with them. And in some places, you'll have data scientists that are machine learning engineers. So I think a lot of people, when they're looking for co-ops or looking for jobs, they look at the data scientist role or they look at machine learning engineer role and they get kind of attracted to that. But and that's how they apply. But there's so many other places that have things that say data analyst, that means the same thing as some data scientists, that have software engineering that tie into the same thing. So I think the challenge in the industry currently is kind of providing this knowledge without actually to the people who don't have this experience, right? Because I can only say this because I have this experience of going through so many co-op cycles and understanding that these differences exist. So I think kind of diffusing this information and teaching people that data science isn't just about the end result. It's more about it's currently it's kind of like a hodgepodge. So I think teaching that is kind of unconfusing that hodgepodge for a lot of people is what the goal should be.
Yeah, that's a very good point you made. Oh, go ahead.
Sorry, I was gonna say actually, like I completely agree with that. On Walkthroughs, when you're going through, you're trying to search for data science jobs and you apply to every single data science position thinking that you're gonna be doing machine learning is complete bullshit. Like, read the job description, try to find out what they really do, because a lot of them, they might just do web development. And there's like, this is honestly the truth, right? They can name it almost whatever they want and the work can be whatever they want as well. So be careful of what you really want to do. And second, I completely agree with Yatin on the fact that data science is way more than just model building. Like you can practice that on Kaggle, but that is like 5% of the picture. There's so much other stuff that you have to do, and that's just like dirty work. It's not attractive to do. But if you really want to learn data science, I think co-ops are the best way, easiest way to do like that dirty work and learn the truth right? The dark side. But maybe you'll start enjoying that. And I actually have a question for Nick, because I saw that too. I think it was some Polish language. I don't remember where it was like the O's with the dots on top, which are like the pronouns. Yeah. So, okay, my question is like, what if, you know, data science, like machine learning, a lot of machine learning is automated decision making, right? But what if, so it's automating the decision a human would make. What if the human already would make a biased decision, right? How do you fix for that?
Yeah, that's a good point. It's like you can't just maybe the way I phrased it was too extreme, but you can't just blame the model, right? The bias comes from somewhere, and it comes from the humans. And yeah, honestly, like I think it's a good goal to strive to be better than humans. Honestly, like we know that these human biases exist, and we should be able to correct these things. Just like when a human makes a decision, there should be control factors surrounding that, kind of controlling their bias too. I'm not just regulating models too. We should regulate people as well. And I also want to add one thing to what you and Yatin said, like. Yeah, 100% agree. Like 90% of the work is data cleaning. Like all the modeling is so easy. It's just model.fit on scikit-learn. That's an exaggeration, but like once you kind of, like most of the work comes in through the data. And also I totally agree with you on the Waterloo Works thing. I would even go a step further. I don't think descriptions are even a good way to look at a job because, especially at big companies, they copy and paste a description for a bunch of roles, right? I think the only way to find out is to go to the interview and like ask them, what am I going to be working on? What did past interns work on? Those are like the two biggest indicators because they can say anything, they can write anything, maybe not even intentionally, just because they're lazy. And like the interview is the only way to find out. And also in terms of experiencing the data cleaning aspect on your own, one thing I would recommend is like, being interested in some subject and scraping the data yourself and then cleaning it and then doing the modeling. Because I think once you scrape data, you'll see how bad data really, like you'll think, oh, this is my toy project. In real life, data can't be this bad. No, trust me, it's worse. Like it's worse than what you scrape from the web. And so maybe that's one way to get a little bit of exposure to that side too.
Yeah, great. And with that being said, I guess someone just sent a question that's very related to what you guys just answered. And sorry, before I move on, Andrea, did you have anything to add on? Because I saw you unmute for a bit.
No, I was just gonna say like my experiences like echo very much like I think one of the biggest misconceptions, I know this is like another one of the questions that we have, but I kind of was like walking into my first like data science co-op, like, yes, I'm going to be doing all of these great models and like life is going to be so great. I'm going to do, it's going to be fancy work. And literally the first day I walk in, the guy's like, my manager was like, yeah, you have to like clean this data first and like actually see what's going on. And I was like, oh, okay. And then I spent like a month just trying to figure out that data, trying to see like what was going on. And it helped that I had like a cloud background and I knew what the services were and like how the logs were coming in and how to like not manipulate them, but like clean them up and stuff. But yeah, it took like a full month out of my co-op just trying to get that data sorted out because the rest of the team had no idea kind of what this data represented, which was like, okay, you're doing this project, but you don't really know what the data is doing. So yeah, I think I definitely agree with the fact that data science is just much more than like picking the model. It's a lot, like there's many steps beforehand that you need to figure out before you actually fit the model or like pick the model that you're going to use.
Yeah, well, with that being said, someone had a question, so I will just go ahead and ask that. The question was, are there paths in data science that are easier to get into for someone who's not in a data science program? So for example, someone who isn't in the data science major that Yatin is doing, I guess, is there any specific paths that you guys would like to sort of guide our attendees towards? And I guess this time we could go sort of in non-alphabetical order, so the other way, because I know Yatin is sort of in that field and you would be able to give us a good insight on that.
Yeah, for sure. I think what you actually notice is a lot of data scientists come from software engineering or computer science. And I think the reason behind that is because it kind of, again, comes back to the point that we just kind of kept hammering. But it's that you, as a software engineer, are going to see that a lot of your work is really just getting data from different places, especially if you're in a back-end position. So I think if you're in software engineering or computer science, that is a perfect way to segue into data, because you maybe have one position, and as a software engineer, you're going to have some interaction with data. And I think the more inquisitive you are and the more kind of you reach out to your colleagues to kind of ask about how do like what's this data doing? How are we? Let's say you're at an e-commerce platform. Excuse me. You might want to know. Okay, so these prices are coming in, and I have to display them at X position. How do I know that these prices are correct, or what model is being used, or what kind of problem are these prices solving? So once you're able to kind of ask those questions, they might actually hand you over some work, be like, oh, why don't you look into this and explore other things that you can do? And I think that's a pretty organic way that you can use to kind of come into data science or data analysts.
Cool, yeah, I totally agree. And I guess to add like a different perspective as well, I would say this is not just for data science. I think almost any role in tech, like what I'm about to say, I believe in, and this the fact that like your major is a lot less important than the projects and the experiences that you do. Like at this point, and even even earlier in my co-op career, like whenever I had an interview, like almost none of it was about the school or coursework or anything I did. It's all about the projects, all about the experience. And so I wouldn't say there's one particular area of data science that's easier to get into. Well, maybe I'll take that back. Maybe it is easier kind of to get involved more in like data analysis before you kind of go into the more higher level machine learning modeling before going to research perhaps. But I guess my point is, even if you're not in a data science major or a computer science major or any like relevant major, as long as you kind of learn these things on the side and pursue projects, then that's what will shine on your resume, and that's what will segue into you getting these roles. And even if you are in a data science program or are in a computer science program, you still, that's no excuse for you to not to pursue these projects or not to pursue these like extracurricular activities that are relevant. Because, at least for me, for example, I took my first like real machine learning course like last term at U Waterloo, whereas like I've been doing data science co-ops like for a while now, right? And if I had just waited for my school coursework to teach me the things that I needed, I kind of, I wouldn't have even gotten into the field until now, right? So you really got to be proactive and kind of look for resources to learn these things online. There's tons of free courses, tons of materials, and kind of build these projects, get that hands-on experience, and that's what will really shine and help you get these roles.
Just to follow up to that from my side, like personally, like I come from a major where there's not a lot of coding involved, and coding is an important part of data science. So how does someone from a major which doesn't really relate a lot to coding keep in touch while they're on a study term so that they can be better data scientists at their co-op roles?
Sorry, go ahead.
Yeah. No, you go for it.
Yeah, I mean, you do a lot of coding, so I guess I can kind of take that one because, I mean, I'm in physics, right? That's like, if you think about it, very far apart from software engineering or data science in general, it might sound like. And I'm sure the person who asked this is also going to feel like maybe math is something where they feel like, I'm not a CS student, I really don't know how to enter. Something that Yatin said was, according to him, the ideal way is to get in through software engineering. And he's right, like a lot of data science, machine learning, etc., is just software engineering. Can you write good code or can you not? Can you understand how like OOP works or do you not? Like those things are important. But something that I'd add is that it's not just the ideal way. I think it's the easiest way. It's like the low hanging fruit. It's not that hard to get into software engineering, and through that, it's not that hard to get into data science because you cannot be a quantitative expert while being an undergrad. It's very hard to do that because they have PhDs which do that, right? So you're competing with people who are like very hard to compete with. But for me personally, I think that you need to leverage the stuff that you've done. That's the most important. And maybe it won't be the exact position that you want. Don't try to like find the position that everyone else is going for. It's just a very generic data science position and try to get into that by giving some lead code test or something or HackerRank, because other people are competing for it and they're probably not qualified, but this resume sticks better, right? It's easier for them to get that. But maybe, for example, I built an app and that app happened to be the exact same framework as this other place, and it happened to be the exact same model. And I was able to show them that, and I was able to show them some modeling that I'd done at that job, which allowed me to get this position, right? So like leverage the stuff you've done, know what you've done well, and also learn everything you can on the side. If you're not in data science, if you're not in CS, you are like, you have a chip on your shoulder, right? Every single time you're going to be judged against this person who has a CS degree and is like learning CS all the time. And you have to learn it on the side. You have to like take 3 different courses on the side along with the 5 you're taking, which are hard enough. So it is a lot of work, but be inquisitive, be curious, just keep learning. And like don't lose hope, and also just like be interesting, because that's interesting. Like it's interesting to be a mathematics student who's also interested in data science, right?
Yeah, I think I'm gonna add on to kind of what Jay said in terms of, if let's say you really dwell on your interests. So let's say like you have a bunch of co-ops that you've done, like worked in different industries, worked in different like places, and like you've actually been you've been super successful, or you have a background in those things. Really leverage that. And I think using the skills that you have, every industry out there has some form of data science, data analytics going on. So I think when you start doing data science or data analytics, the most important part for me that I've realized is that you understand the data that's coming in, and you know where it's coming from, what it's doing, how it works, and all that kind of like aspect to it, because that's what's going to make sure that you can do the proper sort of modeling and whatever not. So for me specifically, like I have done like a co-op term already with cloud, and I had a great understanding of how the cloud works, how the bank was using cloud. And so when I was able to come in, a lot of the questions that maybe the rest of the team had, I was able to kind of answer on the spot. And I was able to give that, provide that feedback and give those opinions and say, okay, this is what this is doing. I don't think it would be valid to like assume that it's happening like this, and then have that feedback. So even if you don't have any like data science or data background, just having knowledge of picking industries that you maybe a little bit are more comfortable with, and you might know the data a little bit better and you know your way around a bit, might be like a good tip in terms of like dipping your feet in, because you feel already a little bit confident in that industry, and you're just like basically taking it a step further and kind of developing new skills around something that you're already comfortable with.
Sorry, can I go? I just have one point that I want to make. I 100% agree. Like if you look at Yatin, right? Yatin had no experience in data science or data analytics at the time. He was just interested in soccer. I call it football. He was interested in football, all right? And he used that to hit up Toronto FC. Who does that? I don't know how to do that. I don't know how to hit up Toronto FC, right? But he did that. He was able to get in through that. So you must do something. Maybe you play League of Legends, right? I play League of Legends. Maybe you do play League of Legends. It's kind of memey, but you can maybe make an app which helps people, right? Or helps you, and uses some data science things and leverage that to get into like Ubisoft or something. You are unique, all right? You probably do something interesting. Your interest is something. Just try to leverage that, use that to build something interesting, do what you like. And it's not that hard, I think.
Yeah. Oh, go ahead, sorry.
Yeah, I think if I had to give like a high level answer based on without coding experience, how do you get in? I would say you really have two choices. You have to think about it from the sense of the employer as well. I think knowing how to code is how you kind of interface with big data for the most part, right? You can't interface with big data, especially if you don't really know how to code in Python or R or any other languages that do so. So if you don't know how to code, that kind of is difficult for you. Your other option is kind of looking at data that is not that big. You'll notice that a lot of financial analysts, so like IB or hedge fund analysts, they do pretty much the same thing, right? They build models, how to forecast pricing, and same with tax companies and accounting companies. So they use data, but at a smaller scale than big tech companies. So I think that's also one way that you can go in as a data analyst into a financial firm or a tax firm or an accounting firm and get exposure to how do you work with data. And from there, you'll kind of build your interest and develop your interest, and maybe you pick up coding as a result of that. So I think just coding isn't the way to get in data science. There's definitely other options out there.
Yeah, definitely makes sense. Just as a follow-up for that question, I guess what places or platforms would you all recommend for someone who wants to get started with data science? I know Nicholas said that there's a lot of free courses, but I guess some of the courses that you guys can probably list right now that we could also let our attendees know, that would be great.
Sure. I guess I can start. My number one recommendation is on like Kaggle. There's these micro courses where you can learn like Python or SQL or like, R. There's a variety of different like data science skills. I would really recommend those. They're quite concise and they're like a really good introduction to kind of get you going. And I think learning these things doesn't stop at the course. You kind of got to apply it, do the projects, or else you're never going to kind of get the hang of it. And so that's like important. Kaggle also has like machine learning courses if you want to get into that, visualization courses. So there's like a bunch of topics there. If you're interested in deep learning in particular, there's a website called fast.ai, which is like, it's not the first course that I took, but it's one that I took eventually. And it's the one that I wish I took first. I think it's an excellent introduction to like a hands-on first approach to deep learning. And in my view, like learning the hands-on and then learning the theory is a lot more motivating and a lot more interesting than the other way around.
I guess I can go next. I would double down in the courses on Kaggle. I remember taking that before an interview of mine. I did like all of them. They're super short, and you know, I was able to like ace the interview because of literally the stuff in that stuff. I'd also suggest like personally like finding out how you learn, right? Like I personally learn by doing. Even if I'm in a position where I have to like, for example, when I learned pandas and NumPy was when Excel became too much of a hassle. Like it was impossible to, like I had data which was like 5-7 million rows. So I had to split my file into 4 different files so that I can open 1.6 million rows in Excel. And I was like, there's no way I can do this anymore. Like this is painful. And it kept growing. So then I was like, okay, there's this thing called pandas and I know Python, etc. So it's just like, you know, I personally learn by doing. And if you learn by doing as well, try to like put yourself in positions where you will be doing stuff, and then you'll learn, okay, maybe I can use this for this. And then that is like in my perspective, that's a better way to learn something because you really understood the purpose of doing that. Other ways of courses, I'd say like just go on Coursera and just like try to take some courses. Personally, I've never done that, so I can't really recommend that too much. I don't have any courses. I tried to take some data camp course, but my free trial expired, so I stopped doing that. But yeah, learn by doing is like my advice.
Right, definitely. I think learning by doing is really, I think, something that I followed as well, because if you just learn something and you don't apply it for a longer time, you probably will forget it in a few weeks or a few months. So like moving on to the next question, this is asked by one of the listeners that we have today. So how do you recommend people should prepare for data science interviews, like especially in your field in specific? How do we prepare for interviews, and what like common tools and technologies are required in these interviews for the person to be successful?
Okay, I'm going to say this with a big disclaimer. None of my data science interviews have had any data science in them. They've just been like software engineering questions and writing SQL queries or kind of interpreting data. So I can't really answer that question. So I'm just going to hand that off to someone else to take.
Yeah, I was just going to say, like, my interview had like, it was more software than data science. So I'll leave it to everybody else to answer that one.
Okay, I guess I could take that one. So I think only a few of my interviews have been data science interviews. Others are also very software engineering focused. Some of them are very SQL focused. So I think if you're just trying to like get a basic understanding of, okay, I want to get the lowest common denominator, right, of doing well in interviews, try to get good at like some basic easy to medium lead code problems. I personally hate that method. Like if a company uses that, I'm not going to work there. But do easy to medium lead code problems and do some SQL questions, and maybe some case studies and try to explain what you're trying to solve in terms of data analysis. But for me, I think that there's two kinds of people. One person who's done some data science sort of work. And for that, you have to understand what you did. You have to understand, okay, let's say you did some hyperparameter tuning. What was being done? Why did you do it that way? Why did you choose that domain? Or, you know, why did you choose that model or that regularization technique or whatever? It's understanding what you've already done, because that's 100%. Like there's no exception. That's always going to be asked, because they want to understand, do you really know what you do in general, right? Second thing that I'd say is that do some projects. So it becomes very easy for you to understand or talk about something interesting, because you don't want to let them have the control of the interview, right? Because if they start asking whatever they want to, you'll go in this like spiral of eventually coming to a thing where you have no idea what you're talking about. But if you control the interview by doing a bunch of stuff and talking about that, you're the expert. So yeah, that's kind of what my general advice would be in terms of interviews.
Okay, I guess I can touch on interviews a bit. Yeah, I guess I've done a ton of data science interviews, and I also conduct data science interviews, so I can kind of give my perspective on kind of what I see from the other side. I would say in general, there's like more broadly than just the coding, is like there's 5 kind of main styles of questions that I usually see. The first one is like a project walkthrough and kind of talking about the things that you've done in detail. The other is like conceptual questions. So it's like whether it's theoretical or, theoretical is maybe the wrong word, but often they ask about the intuition behind various techniques. There's like coding questions. Unfortunately, I hate LeetCode as well, but unfortunately, a lot of data science rules are very coding oriented. And so one kind of the most popular method of assessment for those are these like LeetCode problems. And so that's definitely a thing. And when I say LeetCode, I also include SQL, like Ja mentioned, like that's totally relevant. Another is like kind of a case study style of question, where they kind of give you a hypothetical situation and your objective is to kind of explore how you'd either collect data or how you'd build a model or evaluate a model that's like in production, like what kind of metrics you define. And maybe I'll give a little bit more detail about each one, what I think is important. Maybe the speakers can cut me off if I go for too long, because I think I can talk about this for like an hour. But yeah, for the project walkthroughs, I think what Josh said is like spot on. Like you should be ready for like a 1-minute pitch to describe your project. And then you should be able to handle probing questions about your project for the rest of the interview. And so I remember one of my interviews, the whole interview was just, I presented this little mini project that I worked on. And the rest of the interview was just the interviewer asking the question, why? Like, okay, you did this. Why did you do this? And this was like earlier in my data science career. I didn't know anything. Like I barely know things now, but then I really knew nothing. But he was asking about the intuition behind these things. Like, why did you choose a linear model? Did you check the assumptions of this model? Why did this make sense to you? Oh, why did you choose to plot it this way? Like kind of, in the industry, all you're doing as a data scientist is like making these decisions and looking at trade-offs. And so it's super important that you can describe these in your projects. For conceptual questions, I think, again, there's like tons of resources online. You can just search up conceptual data science questions. You'll get tons of them online. They're super standard. What is regularization? Like what is bias versus variance? Like how do you prevent overfitting? You can kind of look at these online. So I won't go into detail. For coding, Ja covered it perfectly. I won't go into that again. For case studies, it's like kind of just looking at your creativity and explorative capacity, right? Like one recent data science interview that I did, the question was like, okay, so you have for some reason you collected receipts out of the garbage bins at malls in California, and you want to understand how well Best Buy is doing. Like, what steps did you take for that? And it's like super vague and it's super out there, but it's like, you can slowly build up some ideas, right? Like, okay, you have this information about receipts and you have prices of things that people bought at Best Buy versus other stores. You can take a look at, what proportion of sales at this mall were from Best Buy. Is it growing or shrinking over time? What if you expanded this receipt collecting effort? Like, it's all about the questions in that sense. And one final thing I'll add is recently I've done like a bunch of quantitative finance interviews, and these are kind of slightly different as well. Generally, they are focused on like probability and like kind of probability brain teasers or kind of linear regression theory questions. These tend to be more difficult, and you have to prepare for these specifically. Like probability brain teasers, you can kind of Google that term as well for like finance interviews. And those are tough. I find them super tough and I don't really like them that much at all, but that can be, for those kind of roles, that's important as well. Yeah, I think that covers it.
Sir, you said there are 5 kinds of questions. So the first one was project walkthrough, and then conceptual questions, coding questions, and then case study style questions. And was the last one the finance style questions, or was it something else that I missed?
Oh, good point. Maybe I miscounted. No, I think you pretty much covered it. Sure, we can pretend that I plan to have the finance one as the 5th one. Yeah.
Okay, great. Thank you. And is it okay if I can send the list to the chat? In the chat.
Oh yeah. I can send a link after. This is like there's like okay, let me find this. I will send links to stuff.
Okay, great. That's better. Thank you.
I actually have like an add-on to that. Recently, like I had like a bunch of data science interviews, and every single one asked, what is overfitting? And it's weird because it's so basic, but I think something to add on that would be when you go through these like Medium articles which have like listed conceptual questions, always ask a couple of steps further than that. It's like they'll explain you, okay, what is bias and variance? What's the trade-off? And what is overfitting? What is underfitting? Ask yourself, how do you fix that? How do you identify that? All right, because that's literally the obvious next question, and that's in none of these lists. So ask yourself a couple deeper steps in that. Yeah.
Yeah, that makes sense. So for interviews, I guess then just sort of like an overarching idea, would you guys suggest doing a lot of coding questions would help and sort of looking at case studies and brain teasers maybe?
I think it really depends. Like I would maybe even flip it to say the opposite of that, kind of like, don't, if you're applying for a data science role that's not so software engineering heavy, like, don't do a bunch of leak code, right? Case studies, I think it's not super common, I would say, but I mean, it does exist. Same thing with like these brain teasers. Like I would just ignore brain teasers unless you're going for specific roles, like a quantitative finance person or something like that. I think the biggest focus should be on your projects and your project walkthroughs, because like that's what's going to shine in the interviews. And these conceptual questions, they can be like fit into these project questions, exactly what Ja was saying, right? Like, oh, okay, how did you deal with like overfitting in this model, or what steps did you take to resolve it? Did you check that it was doing this in your model, right? It's all about, honestly, just focus on the projects, in my opinion.
Yeah, that makes sense. And yes, from personal experiences, that does, it's very true. Okay, so I can ask the next question. This was also sent by someone, so it's specific to courses at Waterloo. Are statistics and optimization very important for ML, such as CO 250 and Stat 330? If I don't have a math background but only CS, can I still go into grad school with focus on ML?
As someone who's in 5th year now and has thought about grad school, I think I can answer this. I would say most of the courses that you'll see on the Waterloo course calendar are going to help you, especially past the 2nd year. So any 3rd year stat courses that you take, any kind of CO courses that you take, any CS courses that are specific to data science that you take, they'll all be helpful. And I can say this from experience. So there's particular data engineering courses, there's particular data science courses, there's AI courses, there's some theory courses. There's a very big collection of stats and CS courses at Waterloo that offer you these things. So definitely look at those. What was the second part of the question? Something about grad school?
Just a second. So it was, if I don't have a math background but only computer science, can I still go into grad school with focus on ML?
Yeah, definitely. I don't think that's a big problem at all. I think a lot of people actually do that. So not a big problem at all.
Makes sense. Yeah. I know Nicholas probably has also done some of these courses because I did interview him before. So do you have any insights on that as well?
I think Yatin pretty much like nailed it. I don't have too much to add. I guess one thing I will say is like those specific courses you mentioned, like Stat 330, CO 250, like data science is extremely broad, and where you end up really depends on what skills you use. Like, Stat 330 is great. I think learning the underlying theory is important. Optimizations, like learning those foundations, is important, but don't expect that you would use those skills every day, because it really depends on where you end up. And one other thing I will say is, you can look beyond CS and math courses for important data science information. Like this term, I'm taking an econ course, econ 423, which is like time series econometrics, and like this is more data sciencey than a lot of the stats courses I've taken. You're doing a bunch of time series forecasting within economics, and I'm sure there's similar courses in other faculties as well, kind of applying these data science techniques to their fields. And so, expand your horizon and check those out as well.
Yeah, and as well, like from personal experience, I've been doing Econ 102 just because I'm in 1st year right now, and it does have R and it does involve data analysis, and it's pretty interesting as well. Okay, we can move on to the next question.
Yep. So the next question is like, are there paths in data science that are easier to get into? For example, is data analysis easier to get into than data engineering, or is it equally difficult or equally easy to get into all these fields?
Now, I know that's very subjective, so of course you guys can just speak to your personal experiences. So we can just go in alphabetical order again.
Yeah, I don't know if I have like enough experience to sort of talk about this, but I think like just going from what I've seen from some of like the other data engineers who are currently also working with me, trying to go into like dashboarding roles and like just like pure data analysis roles tend to be a little bit easier because the data is kind of already there and all you have to do is kind of like showcase it, I would say. So yeah, I think like some of those roles I personally have seen like people found a lot more easier to get into. And then afterwards, once they got comfortable with the idea of data science, that's when they would start moving into the roles, other roles. I think a lot of it is also just trying to figure out what the roles are. Like for my like example, like the role that I'm currently in, I don't think I would have applied to it if I saw it on Waterloo Works, to be honest, because I looked at the description later on and I was like, this is not what I expected it to be. And like, I don't know if like this is right. But I think the roles that I think is the best to get started with is kind of like, from my personal experience, just like these like POC roles, because I'm currently working on a proof of concept, and it's been great because there's no set, like, I would say not deadline. I would say there's like no things that are like kind of stopping you or they expect you to know. It's kind of like you put in the research and then you go through the entire step of working with the data and then trying to like push it towards like the very end and picking the models and stuff. So I would say like exploratory roles I think are more easier because you just get to like learn more hands-on rather than being expected to have a certain set of like knowledge base in place. But yeah, that's just from like my experience with like one role.
Yeah, I think like this question is the definition of a subjective question. I feel like Andrea thinks that like according to Andrea, it's easier to get into the data analysis roles, like where you're dashboarding and kind of presenting your findings, etc. I personally think for me they'd be harder to get into than a data engineering role, right? It really depends on who you are. In this case, priors matter. Like you have to be 18 unless you're Diki, you're 12. You have to be 18 to be here. So you've lived 18 years of your life. If you're in second year, you've lived 19 or whatever. You must have had some set of experiences and skills which make you more inclined to go some way or the other. Are you good at presenting some findings? Then maybe you should go towards a dashboarding role. I know a lot of data scientists which cannot do that. All right, they're really good at machine learning building, or they're really good at data engineering, but they're awful at that. So that question instead should be, for me, what is the easiest for me? As I said before, for me, it was easy to get into a role which is versatile. So try to maybe find a team which is like allows you to experience different assets of data science, allows you to present your findings, allows you to build an app, allows you to do data engineering. It's not very common you'll find that. Probably in small teams you'll be able to do that. But maybe that first step will allow you to go into a position to find, okay, for me, which is the easiest one to get into. So yeah, I really can't answer that question, but maybe it's like a question you should ask yourself,
Yeah, I totally agree with John. Just to like build up on that a little bit. I think for any role you look at in data science, there's like a huge spectrum of like expert level people versus like very beginner level people. And so getting into each of these things is like, yeah, depending on what skills you have, and then looking for the most beginner level version of that role. So maybe the better question is, well, where are beginner level roles more common? I think maybe that's a little bit easier to answer, right? Like if you're looking at fundamental machine learning research, or creating new neural network architectures, maybe you're not going to find many beginner roles there, right? Or maybe if you're working on, like a machine learning engineer who's deploying these models into production on a regular basis, yeah, maybe there's a narrow gap for a beginner. But yeah, exactly what Andrea and Josh said, like maybe these exploratory analysis roles, yeah, maybe there's more beginner roles available. But of course, these roles can scale up to expert level, huge impact roles, but like there's just beginner opportunities available. Or if you have like a coding background, then the software engineering roles, maybe you're not doing too much model development, but just kind of the infrastructure around it, maybe there are some more of those available. And so, yeah, just some of my thoughts.
Yeah, I agree with everybody here. But yeah, I think, so coming back to my point about there's two different ways, like coding is a gatekeeper and there's data analysis. I think if, let's say the audience is first year, second year mainly, right? How do you get into data science? I would say the two most common paths that I've seen is you have people who know how to code again, and they go into a hackathon, right? They find out that they're going to become a good software engineer, and they go into software engineering, and there they find themselves that, okay, I'm in an infrastructure team, or I'm in a backend role, and those two things are really closely tied with data engineering. I would even go as far as to say that data engineering is software engineering. There's really no difference. Slight differences, but right, it's software engineering. So if you're a software engineer, you're going to find it much easier to transition into data engineering. It's going to be more organic for you because a lot of data engineering depends on cloud technologies, infrastructure, backend engineering. So if you're in that position, or if that's where you're looking to go to and then transition to data science, that's one thing you can do. The second part, again, is you don't really have a coding background, but you find kind of making visualizations exciting. You find doing data analysis on small sets of data exciting. And from there, if you have more of a mathy or a stats-y background, from there you can go into a more front-end facing role in data science. You can kind of be that one interface for business stakeholders to the tech team. And then from there, you can kind of work backwards into actual data science and maybe data engineering. But those are the two most common things that I've noticed.
Right, that's pretty cool. And to kind of go back to the theme of the event, which is exploring different parts of data science, I wanted to ask a question regarding that. Is how can we leverage the co-op program that we have at the University of Waterloo to actually explore different fields of data science? Like, it's very easy to get your first job in data analysis and continue doing all jobs in the very similar field. But how do you actually go forth exploring different fields? For example, you want to jump in from analysis to engineering to machine learning engineering. How do you actually do that? It's slightly harder than doing the same role again, but what is a efficient way of doing it between your co-ops?
Maybe I'll start with this one because this is kind of exactly what I've tried to do. So yeah, like my first one, I kind of did data science, and then I went to like open source like engineering, and then I kind of went into performance engineering, and I did research. And the next term I'll be doing like quantitative finance. It's like, you know, as diverse in data science as I could make it. And unfortunately, I don't have like an easy answer for this. It's like, it's kind of tiring, to be honest, because the preparation for each role is very different. And you got to do kind of slightly, you know, projects you do may be relevant for multiple roles, but in order to really get some of these roles that you want, you have to do specific projects to develop those specific skills. And I think the key is, you know, find some way to stay motivated. Like, you know, this is the only time in your life when you'll be able to just try something for 4 months and leave, right? When you're in full time, you can't just stay at a place for 4 months and leave. You got to stay for like a year and a half, or else it looks bad on you. And also, like, people are often worried about, oh, if I don't build on my previous co-op in my next co-op, then what's going to happen is I'm going to be less experienced when I go to full-time, or I'm not going to be able to get as good of a full-time role. Just realize that you're going to be in full-time for probably the rest of your life until you retire, right? You have so much time to build your career. And this is the only time where this is the most convenient time for you to do that exploration. And for me, that has helped me stay motivated in saying that, you know what, I'm not just going to do my next role as like an upgraded version of my current role. I'm going to try my best to try something different, right? Even though it's going to take time to prepare, even though I'm going to get slapped in the face at interviews, like, because I don't know how the interviews go, but at least like trying something and like failing now, it's like, it's inconsequential, right? Later on, like, there's no long-term impact of not doing so well now, or not building one career path now, but doing the exploration is like super valuable. So yeah, no easy way. Unfortunately, I wish I could say there was, but just kind of keeping the motivation and actively searching out different roles is important.
Yeah, I mean, I completely agree. I cannot stress enough how interesting it is that we have only, like, we go to a company for 4 months and we get to experience so much, again and again and again for like 5 years, right? So if I were to kind of advise someone, would be to explore different areas. I personally went from like a performance engineer role as well into research, into development, into data science, which was mostly just data engineering, then into data science, which was also, again, just machine learning infrastructure engineering, and now into data engineering. But I'd say that, yeah, be prepared to not know what you're talking about almost every single time you enter a co-op. All right. It's kind of sad. All right. The first month is going to be a grind. But I'd also suggest that I understand why someone would want to build on their previous experience, right? Maybe, they lack certain things which would allow them to be able to get that next job, right? Maybe they need to build on certain experiences so that they're competitive with other people to be able to now get that job. Nick is coming from a place of like, just being set, like he has a CS degree from Waterloo, right? And when you see that on the thing, and then you see like, oh, he went to a TOS program, etc., like, and he interned at Google, like, yeah, that gives him the passport to try out whatever he wants. Some of us or some people might not have that, right? So if that's the case, I understand if you want to, do the same thing again to build your credibility. But I 100% agree. Try something new. If you apply for a job and you know more than 60% of the content they're going to do with the job, don't do it. Don't apply for that job because you're not going to learn that much. That's something that I try to like strive for. But yeah, that would be my general advice in that.
Yeah, thank you very much. I guess as we only have 15 minutes left, I can just open the floor for our guests to ask any questions. But I got one question already. It's kind of a long question, so I'm gonna read it out and then you can, I guess, answer it in parts. So, is it true that you need high marks to get data science co-ops? What's the grade range needed? And if your grades are low, what can you do to get data science co-ops? So the focus is on grades, so sort of like what's the grade range needed, and do you really need high marks to get good co-ops? Go ahead, Yatin.
Yatin, you can go ahead. Yeah.
All right. I would say, in short, in general, grades can't qualify you for a job, but they can disqualify you for a job. That's all I'm really gonna say. You're gonna lose positions if you have less than a certain grade, but if you have higher than a certain grade, you're not gonna really gain anything. That said, I know Nick is looking at quant finance roles, and I know that they might be a little bit more particular. So he might be able to kind of branch out into that a little more.
Oh, sure. Yeah. Yeah, some roles, yeah, I would completely agree with what you said. And I think some roles do have like grade cutoffs. I can't speak specifically about what those might be. You know, sometimes, especially in like fundamental research, especially if you're more on the theory side, they may look at your marks, and like some of these big firms in finance also may look at your marks. But I think at the end of the day, it's like, I will say it really doesn't matter that much. Like, you know, for, I would say, a vast majority of roles, it doesn't matter. Yeah, I guess I'm just going to put it there. I think your experiences and your projects will speak a lot louder. And like sometimes there are grade cutoffs that may disqualify you for some roles, but the vast majority of roles, they don't matter as much as you may think.
Yeah, I was just going to say what Yatin said. Like, for the majority of the roles that I have seen, like, I don't think a single one of them has kind of like asked for my marks or like marks are definitely not like the biggest thing. So yeah, I would say that. And then second, I would say, just to add on to like the previous conversation, like in terms of like growing and developing, I've been at RBC for the last 3 co-ops, and it is something that a lot of people question me for, and they're like, why did you stick with the same company for like 3 co-ops? And the reason that I give is that because I have the opportunity to explore. So let's say you want to stay in the world of finance, or you want to stay with a certain company, but you also want to explore different parts of the company. And so that's where I started off as like working in data security, and then moving into cloud security as a developer, and then moving into data science. And so I think if you want to, I guess, stick with the same company or the same kind of area that you're in, but also explore, networking is a huge thing. And within some of the bigger companies out there, there's definitely the room to kind of explore and take chances and take risks with the roles that you have. And if you can build a reputation in one company and say like, okay, like you did a really good job in this, then I'm pretty sure they're more than willing to like give you up into like another team to learn a different skill or something like that. So,
Yeah, I mean, I can personally say that, yeah, certainly grades can disqualify you for certain roles, but they're very specific. I mean, if you're going for quant finance and those kind of roles, they will look at them and they probably will disqualify you if you have like below, I actually don't know the number, but a 70, I guess I'll say a 70. I can be sure of that. And there's certain companies which look at grades heavily as well. But I'd also stress on like performance evaluations do matter as well. If you're applying through Waterloo Works, it really like, to me personally, like if I was hiring someone, I'd really want to know what other people who worked with that person thought of that person, rather than the grades, which might or might not be a great indicator. So yeah, grades matter, but your evaluations matter as well. But you know, if you don't have that good grades, don't worry about it. Most positions do not care at all. Like they really don't care. Yeah.
Yep. I think that pretty much answered the question really well. And just another question that was there was that how different is it from working for a big company in your specific field, and how is it working for a startup? How's it like working for a startup? And why do you think students should have both these experiences before they graduate? Should they or should they not? And if you think they should, why do you think they should have these experiences?
Oh, go ahead, Andrea.
Yeah, so I was just gonna say, like, I have been working at like a big company for a while, I would say, and the great thing about big companies is that they have like I guess the resources in order to like pursue certain projects, and they have the abilities, the capabilities of kind of doing things on a larger scale. And when they put their sets on a project, like it'll get done and there'll be people to support you, and that's great. But one of the negatives that I've seen about bigger companies is that there's a lot more barriers. There's a lot more things that can prevent you, whether that is like policies that they have, security issues, whatever it might be, like their image. And there's a lot of different things that kind of like prevent you from, I could say, exploring to your full potential. And that is one of the reasons why I'm personally looking to start going into like the startup world, because I think there's so much more to learn from a startup position as well. Just being hands-on with the work and not really having some of the certain barriers or like limitations that you might have for your work. With that being said, though, I think there is a benefit to having a varied diversity in your work and the companies that you're in, because of the fact that like things that you learn at a big company, you're not going to learn at like some of the smaller companies. And I'm saying this from like some of the mentors that I've had who have done both. And they said, Andrea, look, like you work at a big company your entire life. That's great. Like you'll be set. But at the same time, like think of all the some experiences and the learnings that you would get if you're working hands-on in a situation where you might not have a lot more barriers for you. And I think that's the biggest thing is like, yes, working at a big company, there's more resources, there's more capabilities, but at the same time, there's a lot more to limit you as well. Whereas in a startup, it can be the complete opposite, or maybe like not a startup necessarily, but maybe a smaller company out there.
Yeah, I completely agree. I'd say that the 4 positive things you get from working at a big company are, the first is name recognition, right? If you work at a startup, which, sometimes I call stealth startups. I have no idea how many stealth startups there are. Like at that point, you put that in your resume and no one has any idea what you're talking about, right? So some startups people don't know about. Big companies, it's easy to recognize their name. Second is the support systems and resources that they offer. You will have mentors, you'll have buddies, you'll have like other support systems, you'll have large amounts of resources for your projects. The third is, I actually did have a third point, but I forget sometimes. But the third is basically like when you're at a big company, the amount of impact, as Andrea said, you can have by not doing that much, to be honest. Like I remember that when I was working at TD and this very specific lab, they were working with this data science project, and I spent like 3 days on one specific deal or something that I was working on, and that 3 days of work ended up like getting 9 million in revenue. And it was a pretty easy thing that I did. So it's hard to do that at a startup. And the fourth thing that is a positive thing about working at a big company is that amount of people that work at that company. And you can learn from so many more people at a company like that. And they have more time, they can help you out. You can hit them up and they'll be like, all right, I am down for a 30-minute coffee chat. At a startup, those things are not offered, right? But the positives for me at a startup, and the reason that I'm going to be working at a startup is, first is that you have to work with constraints. And those constraints allow you to grow in ways you never thought you would be able to do that. So maybe you'll find out some new technique that you could use because of that given constraint, right? The second is that the mission is very clear. At a big company, mission sometimes gets diluted. You don't really know what the whole point is. At a startup, it's quite kind of easier to keep track of that. And the third would be that you feel like you're in a very versatile role. At a big company, they can hire specialists. When you go in, you're more likely to be a specialist than a generalist. And at a small company, you have to wear many hats. You have to do many things. So I think those are like the pros and cons of like working at a big company versus a startup in general.
Maybe I can touch on a slightly different perspective. I totally agree with what Andrea and Jess said about like companies. Maybe I can talk about kind of a big company versus like an academic lab on the research side. So really the big difference kind of comes down to these big tech companies have huge budgets and huge compute resources. So if you're doing kind of machine learning research at a company versus a lab, generally at this company, you'll have a lot more resources. Versus labs usually have a lot more freedom in the research they pursue. They usually have, they're a lot smaller. And so you can kind of, it's more, because since you're an academic lab and you don't have to contribute to a company's mission, the types of things you can work on are very different. And also, I will say that machine learning research in industry, and when I say research, I don't mean like kind of R&D for products. I mean research in the sense of like publishing papers, is I think getting less and less funding over time, because it really just doesn't make sense for these big companies to keep funding research that doesn't help their company at all. And so if you're interested in the research aspect, which I mean like publishing papers, the future is a little bit uncertain for at these big tech companies, but I guess it'll always persist in academic labs. But again, it's a sweet deal when you're at a big company. You get like paid well, you get these perks, and you get these resources, and you can do the research. I don't know if that honeypot's going to dry up anytime soon. But on the side of research, where it's applied research, where you're actually contributing towards a product, then of course these opportunities will continue to be available at these companies. Whereas at academic labs, you won't really have the opportunity to apply these data science techniques to an actual product. And also, before I stop, a little bit of a shameless plug. I will link a post in the chat, which kind of covers a lot of the things I talked about today. So hopefully that's helpful.
Thank you. That is
That's a solid answer, Nick. Go.
Sir, that's very informative. Thank you very much. Someone else has a question and they would like to ask you. So what I'm going to do is I'm just going to ask them to unmute themselves and they can ask the question.
Hi, so I had a question about side projects. So to all of you, so when you were like new with little experience, so what kind of side projects did you have? I'm in math, so I don't have a lot of CS experience. So do you have any recommendations on like what to start off with or something?
I think personally, you pursue your passion. I think Jay also touched on this previously. As long as you find something that to find yourself motivated is a big push, right? Like I think Nick also touched on this. I think as long as you can find ways to motivate yourself, you'll always be able to achieve something. And that kind of applies here too. So find something that motivates you, right? It doesn't have to be that, oh, I don't know coding, so I can't build a web app or something that visualizes what I want to show. If you find motivation for that, you'll be able to work backwards and kind of pursue that. So for example, you want to have a web app, something very simple that I did very early on in my first year was a web app to visualize stock tickers and a bunch of metrics for them over time. And basically that stemmed from my interest of finance, because I had a couple of friends who were in math and BBA, and they were like building finance projects as well. So I was like, why don't I try this out? And I just worked backwards. I was like, this is my end goal. So what do I need for it? I need to learn how to visualize. I need to learn how to interface with data that's coming in from different sources. And I need to learn how to set up a web application. So once you have those steps down, what you can do is work backwards and kind of break those things down into smaller problems. I think that's also one of the key things, right? You don't want to have a side project that looks at you as a big thing, right? You want to break it down into smaller steps and do it over time. And you'll realize that once you finish what you intended to, you'll have so many more things you can take it towards, right? You don't have to have this one end goal and you stop when you're there. I think that's the beauty of it as a passion project or a side project. You can take it wherever you want to. So once you're done with it, you'll see, oh, look, this is a cool feature, why don't I add this on? And I think that's how you kind of learn and grow. So that would be my advice for that.
Yeah, I completely agree with that. I'd say that there's a couple of things that I'd say. One, which is don't do projects which are obviously the first time projects which are out there. All right. Don't do the Titanic dataset project with exact same way someone else has done it. That looks awful in a resume. Like everyone knows that's complete bullshit. All right. So try to do something that you're interested in, as you said, right? Like you're probably interested in something, and it's not that hard to build it from top down. You don't need to know the bottom. You don't need to know the details of everything, right? And second is that, yeah, like it's important to build something, as I said, it's important to build something that you're personally interested in, because that is something that is interesting that you want to talk about as well. In an interview, for example, when someone sees it, they're like, oh, wow, you built this, like this, I've never seen that before. Like, can you talk a little bit about that? And then you can come at it from a perspective of the product and then into the technology. And that's, I think, kind of interesting.
Yeah, I completely agree with the two previous perspectives. I just, in terms of some things that I did as well, you know, I agree that the Titanic data set on your resume is like awful. Or if you just train MNIST on the class, you know, like a simple CNN on MNIST, it's like, okay, great, you followed the tutorial on a TensorFlow website, like good job. But I do think those are really good first things to do before you make an actual project, right? Like Kaggle, there's tons of competitions and there's tons of beginner competitions. Just copy what someone has done, play with what they've done, expand what they've done. And now you've learned something so you can start an actual project from scratch because you kind of learned what they already did. That's a great way to kind of take it, modify it, play with it, learn a little bit, and then do your own afterward. And I think that's a good way to get started. Another one is like open source. I think that's kind of underrated as well, where you know, a lot of these frameworks that you're using, that when you get started, you'll kind of learn about them, understand them. And then if you kind of visit these open source implementations, there's tons of beginner bugs or beginner issues available. And that's a great way to build those skills, just kind of contributing back to these libraries. And I think open source contributions look really good on a resume. Like they're like, the effort to impressiveness ratio of open source is like really high. And I would like highly recommend checking that out. I guess that's once you're a little bit more advanced. And I think also kind of the working backwards thing that Yatin said, it's like, I completely agree. And you can even take that a step further. If you're aiming for a certain role and you know kind of approximately what they do day to day, work backwards and figure out what skills you need to learn and then choose a project for those skills. If you want to be a data analyst, or if you want to do like visualization or dashboards, just do a visualization project, right? And it can be in whatever you're interested in. And there are definitely tons of examples on the web where you can kind of look at as a starting point and then kind of build your own on top of afterward.
Right. I think that was really helpful. Like, I can definitely agree with all the points there. Personally, even I tried to use the machine learning, the Titanic data set for machine learning. And yeah, that's a good place to start, but try to build something that you're really passionate about. Like we're coming close to 8 p.m. now. In fact, it's 8:01. We have one more question from somebody in the chat, and that is, are biostatistics courses like helpful for data science?
Short answer, yes. Like the statistics concepts you learn are applicable everywhere. And especially if you want to go into biostatistics career-wise, like, yeah, super helpful. I think the statistics will transfer no matter what.
Yeah, I think we're at the end of our panel session. Was there anything else that anyone would like us to ask? I haven't seen any questions so far, so I think I'm gonna take that as a no. But other than that, thank you very much for our wonderful panelists for answering the questions, and your insight was very helpful. I'm sure everyone can just use the information you've provided, and we can learn as well. Also, thank you to our guests for attending and staying for the full 1.5 hours. Really means a lot. So just to give you a heads up, can you guys also please fill out the form that's been sent on the chat? I can send it again, actually. So this form is just a little feedback form that would be useful for us in the future. So please fill this out. But yes, thank you very much. Very useful. And yeah, have a good night, guys.
Thank you, everyone. Thank you so much.
Bye.
Thanks for hosting. See you.
Thank you.
Be sure to watch the podcast. Oh, sorry.
Bye.